Hello everyone and welcome to our mini test solving. So first I decided to change my practice so I can share the mini test at the start of the lesson, because I figured that many people do not watch the lesson first, so the mini tests are maybe more of the practice for those who already think they know it. So here is the mini test, you can pause and solve it. And if you're already here for the solving, let's get right ahead into solutions. First, we have to figure out if this is growing or decaying. We can either graph it and see, or we can look at the properties or the conditions. So our A would be 2/3, which is 0.66666 periodically repeating, and our exponent is a positive x. This isn't the right marking, but I'll just use it to make an explanation easier. I think this means e to some power, and this marks the exponent. So you don't have to write out e to the power of something like this, because this is like two layers. You just write exp, and that automatically means e raised to the power of whatever it's in the brackets. I think. I forgot this, so don't take my word for it. I just know that this is not the correct marking. It's just easier to explain. So our two conditions are what the exponent... Sorry. Our conditions are that either the exponent is negative or a is between 0 and 1. Only one of them can be true at the same time for the function to be decaying. We see that a is indeed between 0 and 1, as 0.666 periodically repeating is under 1 and over 0. And then we see that x is positive, a plus in front of it, meaning that exactly one of these two conditions is true. Therefore, the function is decaying. For our second task, we had to analyze the function and determine the range, domain, and the asymptote. So we know that the domain of exponential functions is all real numbers. And then we have a that is greater than 1 and x that is positive, so the function will be growing, meaning that our lowest value will be 0. So our range will be... Sorry. The bottom limit would be 0. Our range will be positive numbers, meaning no negative and no 0, as 0 is never touched by this function. So the y value cannot be 0, meaning that codomain is 0 to infinity, and y is 0 as our asymptote, which are the solutions. For the third one, technically this one would fall better under series or sequences, but it sort of fits here too, so let's just try to solve it, right? A population doubles every year. If you start with 500, how many after 3 years? Let's assume no one in the population dies within the 3 years. So our population after 3 years would be a certain starting value times the ratio to some exponent. N means at the population at the end, and 0 is the population at the start, R is the ratio, and X will be the independent variable, or time in this case. So these are our values that we just put in, and we calculate 4,000. A population with no deaths or losses in its numbers that doubles every year. If you start with 500, we would have 4,000 after 3 years exactly. Thank you so much for tuning into the mini test solving. I hope everything went well, and I'll see you on in our next video. Bye!